Hello everyone. So in this video, let's talk about identifying isomers. So lately, a lot of students have been asking me, how do you identify isomers? And the simple answer is as follows. For isomers, it has to have the same formula but different connectivity. Again, the same formula but different connectivity. Some of you are going to be like, what does she mean by connectivity? So connectivity, I'm saying how are the atoms arranged? If that doesn't make sense, I have these examples below to help you out with that question. So if you look in the first example, you have 2 carbons, 4 hydrogens, and 2 chlorines. Okay? If you look on the right, you have 2 carbons, 4 hydrogens, and 2 chlorines. So then you say, okay, isn't it the same molecule? No, it's not the same molecule. What is happening? So if you look on the left, you have 2 chlorines on one of the carbons. And if you look at the molecule on the right, you have 1 chlorine on each carbon. So again, it's not the same molecule. It has the same formula and it has different connectivity, and that's why these molecules are known as isomers. So again, same formula, different connectivity. Again, the one on the left, both chlorines are on 1 carbon. The one on the right, there's a chlorine on each carbon. But again, you have the same formula. Now let's go to the bottom. You have 2 carbons, 6 hydrogens, and 1 oxygen. On the molecule on the right, you have, again, 6 hydrogens, 2 carbons, and 1 oxygen. So how is it changing? The arrangement, the connectivity. If you look at the molecule on the left, you have an alcohol attached to a carbon. If you look at the molecule on the right, you have an ether, you have an ROR. Again, I'll make it simple in case you haven't learned functional groups. So an alcohol is an oxygen and a hydrogen. So if you look on the molecule on the left, the oxygen is attached to 1 hydrogen and to 1 carbon. The molecule on the right, again, the ether, ROR, because you have like a methyl, an oxygen, and then a methyl. Again, it doesn't have to be a methyl group, it has to just be an alcohol group. But again, if that's too confusing, just know that the oxygen on the right is attached to 2 carbons, the oxygen on the left is attached to a carbon and a hydrogen. And so again, the connectivity is different, but if you count the atoms, it has 6 hydrogens, 2 carbons, and 1 oxygen, and therefore these 2 molecules are isomers. Pro tip: if you are on a quiz or on an exam or whatever, and in the molecules listed, it has a different number of atoms, like an extra carbon or an extra hydrogen, it is not an isomer. To be an isomer, you have to have the same formula. So if you do not have the same formula, automatically cross it out. The answer is going to be no. Now, if you have the same formula, you need to check out how the molecule is arranged. And again, there are different types of isomers, which you'll learn on later on in the semester, like stereoisomers and diastereomers. And you can go check out my videos on those. But again, for the sake of just identifying isomers, it has to have the same formula and again, different connectivity. It takes time to create this content, so please follow, like, share. And again, thank you for watching.